Good afternoon, dear students. Our next session that is regarding potassium permanganate, the properties, structure, preparation, etc. of potassium permanganate. See here, this is this potassium permanganate. It is this compound, the central metal atom, that is manganese. Okay, manganese, it is the central metal atom, and it is coming under the transition metal series in the first series, isn't it? First transition series. Scandium, titanium, vanadium, chromium, manganese, isn't it? Manganese atomic number 25. So here this potassium permanganate, it is the salt of permanganic acid. Potassium permanganate, it is the salt of permanganic acid. The formula for permanganic acid is HMnO4. Okay, HMnO4, that is the formula for permanganic acid. And also this is an unstable acid. It is a highly unstable acid. Highly unstable acid. So this the ore of potassium permanganate, that is we are preparing this potassium permanganate or extracting it from the ore manganese dioxide. Manganese dioxide. So this MnO2, it is called as the pyrolusite ore. So potassium permanganate, its ore is MnO2 or the pyrolusite ore. It is extracted from this pyrolusite ore. Okay. So first is the industrial method of preparation. Industrial method of preparation. Industrial method of preparation. See, this pyrolusite ore, that means MnO2, manganese dioxide, it is fused with potassium hydroxide. MnO2 is fused with potassium hydroxide in the presence of air. That means in the presence of oxygen. So the reagents are MnO2 fused with KOH in the presence of oxygen to give potassium manganate. The formula for potassium manganate is K2MnO4 plus 2 molecules of H2O. Here also 1, 2. Only then the equation will be balanced. Here it is 2 MnO2, here it is 4 KOH. Okay, so the equation will be balanced. So this is the industrial method of preparation. MnO2 fused with KOH in the presence of air, and we will be obtaining potassium manganate. Potassium manganate. Okay, see here this potassium manganate, it is then treated with water. Potassium manganate treated with water, and while treating with water we will be having a green solution of potassium manganate. So through this green solution of potassium manganate we are passing chlorine over it. Okay, so this the purpose of using chlorine is that it has to be oxidized. This potassium manganate has to be oxidized to potassium permanganate. So this green solution, it is passed over chlorine gas. Okay, so the equation will be 2K2MnO4, that is potassium manganate plus chlorine giving 2KMnO4, that is our required compound KMnO4, potassium permanganate plus 2 molecules of KCl. Okay, so this is the industrial method of preparation of potassium permanganate. So here in the presence of chlorine means it is oxidizing. Potassium manganate is oxidized to potassium permanganate, KMnO4. Okay, so here when this solution, see, it is a mixture of KCl as well as potassium permanganate, isn't it? As you know, potassium chloride, it is a soluble salt, isn't it? It is more soluble in solution. That means this KCl, it will be remaining in solution, and this potassium permanganate, it is less soluble. Potassium permanganate is less soluble, while KCl, it will be in solution. So we can separate out this potassium permanganate from the mixture. Okay, so this is the method of preparation. Then another method, that is by electrolysis. Okay, by the electrolysis. So here during electrolysis what happens is that potassium manganate K2MnO4, it is oxidized to KMnO4. It is oxidized to KMnO4, 2K plus MnO4, 2 minus. Okay, again water, it will be ionizing as H plus OH minus. So here in this process of electrolysis, see here this manganate ion, it is oxidized to permanganate. Okay, so this permanganate See, normally we all know this anions will be moving to anode, cations will be moving to cathode, isn't it? So here here the anion is MnO4 2 minus, isn't it? The manganate ions. So this manganate ions, it will be moving to the anode. Okay, manganate ions will be moving to the anode, while at the same time hydrogen gas will be liberated at the cathode. Okay, so we can write the reaction at anode and cathode. Okay, so at anode manganate ions, permanganate ions will be there. So reaction will be MnO4 2 minus, giving MnO4 minus plus 1 electron. Okay, so this one, it will be potassium manganate, it is green in color. Here this manganate ion, it is purple in color. Okay, so this is permanganate ion, and this is manganate ion. Okay, manganate ion. So this is the reaction at anode. That means this permanganate ions will be moving to anode. Then the next reaction at cathode. So at cathode, hydrogen gas will be liberated, isn't it? That means 2H plus 2 electron giving H2. So this is the reaction at cathode. That means at cathode, hydrogen gas will be liberated. So this is the reaction. And also after electrolysis, what happens? At anode, we will be having purple colored permanganate solution, and this purple colored solution, it is evaporated. So on evaporation, what happens? On evaporation, we will be having the beautiful purple colored crystalline solid. Okay, purple colored crystalline solid. So this is regarding the preparation of potassium permanganate. So you have to study these two methods of preparation. The first one, that is the industrial method of preparation using KOH and manganese dioxide or pyrolusite ore, and the second one, that is the electrolysis. Okay, then the next one, properties. Properties of potassium permanganate. See here, about the color, it is a purple color, then it will be in the crystalline form. Purple colored, it is a crystalline solid, isn't it? Purple colored crystalline solid. Then it has got a melting point of 523 Kelvin. Soluble in water, fairly soluble in water. These are some of the physical properties. And also in the case of MnO4 minus potassium permanganate, MnO4 minus, this the metal present there is manganese, isn't it? The transition metal is manganese, and in this manganese, it is in the sp3 hybridized state. Okay, so you have to study the structure of this potassium permanganate also. The structure, it will be like this. It will be having a tetrahedral geometry. Okay, MnO4 with one negative charge. So 4 oxygen atoms are there. So double bond O, then again double bond O. Okay, then again a single bond O minus. Okay, so this is somewhat a tetrahedral geometry. Okay, it has to be come here. Okay, this O minus has to come here. Then it will be having a tetrahedral geometry. Tetrahedral geometry. Okay, so MnO4 minus, it in manganese, it will be in the sp3 hybridized state, and the 4 oxygen atoms are surrounding this manganese ion by a tetrahedral orientation. Okay, then the next is the chemical properties. Hope you are clear with this geometry. You have to study both the structure of dichromate as well as potassium permanganate. Then the next is the chemical properties. Chemical properties. See, first reaction, action of heat. Action of heat. See, potassium permanganate, KMnO4, on heating to a temperature of 200 degree Celsius, giving K2MnO4. That is, we are getting this potassium manganate, K2MnO4 plus MnO2 plus O2. Okay, so this is the action of heat. That means potassium permanganate, is the spelling right? Permanganate. Okay, so it is on heating we will be having potassium manganate. Okay, then again on further heating, that means on heating to red hot, at red hot, that is again we are increasing the temperature. That means while increasing the temperature, this K2MnO4, that means this potassium manganate, 2 molecules, it is again decomposed to give permanganate. That is, the formula will be K2MnO3. Again 2 molecules of K2MnO3 plus oxygen. This is potassium permanganate. Don't get confused with all these three. Potassium permanganate. First one is potassium permanganate, then potassium manganate, then potassium permanganate. Okay, ITE. So the formula is K2MnO3. So here decomposition of potassium manganate takes place to give potassium permanganate and oxygen. Okay. Then the next reaction, the second reaction with alkali. See here, 4 molecules of KMnO4. Alkali means a strong alkali we are using here. That means in the presence of 4 KOH, potassium hydroxide, on heating we will be having 4 K2MnO4. Again we are having potassium manganate, isn't it? K2MnO4 plus 2H2O plus O2. Okay, this is potassium manganate. Okay, so this is the reaction with alkali. This permanganate, it is it will be reacting with alkali to give potassium manganate. Then the next reaction with sulfuric acid. The third reaction with sulfuric acid. See here, you have to go through 2 reactions with concentrated sulfuric acid. Then the first one is with cold concentrated sulfuric acid. That means in the on reaction potassium permanganate on reaction with H2SO4 sulfuric acid, giving the products will be Mn2O7. Mn2O7, that is manganese oxide, plus potassium bisulfite 2KHSO4 plus H2O. So this compound Mn2O7, that is manganese oxide. KMnO4 plus H2SO4, concentrated sulfuric acid, cold concentrated sulfuric acid. We will be having manganese oxide plus potassium bisulfate plus water. Okay. Again this manganese oxide, that is Mn2O7, 2 molecules of manganese oxide. Then again it will be decomposing to give manganese dioxide, 4MnO2 plus 3O2. Okay, so that is the last reaction. So here this manganese oxide again decomposes to give manganese dioxide and oxygen. Okay, then the next reaction, that is with warm concentrated sulfuric acid. So here 4 KMnO4 plus 6H2SO4, 4 KMnO4 plus 6H2SO4. Here KMnO4 reacts with sulfuric acid to give K2SO4, potassium sulfate, 2 molecules, plus manganese sulfate, MnSO4, plus 6H2O plus 5O2. Okay, so with warm concentrated sulfuric acid we will be having potassium sulfate, manganese sulfate, water and oxygen. That is 2 different reactions with cold sulfuric acid and warm sulfuric acid, warm concentrated sulfuric acid. Then the next one, the fifth reaction with hydrogen, that is on heating with a current of hydrogen. potassium permanganate 2 molecules, 2 KMnO4 plus 5H2 giving 2 KOH potassium hydroxide plus MnO manganese oxide plus 4H2O. Okay, so using solid KMnO4 on heating in the presence of hydrogen gas, we will be having potassium hydroxide, manganese oxide and water, 4H2O. Then one more reaction. A mixture of KMnO4 and oxalic acid, potassium permanganate and oxalic acid, it will be catching fire very easily. It will be catching fire spontaneously or very easily. It will catches fire. A mixture of potassium permanganate and oxalic acid. And also again, same is the case of a mixture of potassium permanganate and glycerin. Potassium permanganate and glycerin, it will also catches fire very easily. Okay, so this reaction also you have to notice. Okay, so these are some of the important reactions. Then the next is, as you all know, this potassium permanganate, it is a very good oxidizing agent, isn't it? It is a very powerful oxidizing agent even in acidic medium or alkaline medium or in neutral medium. Okay, so you have to go through some of the oxidation reactions of potassium permanganate. Okay. So first you have to go through the oxidation of potassium permanganate in acidic medium. Oxidation of potassium permanganate in acidic medium. So the first reaction, 2 KMnO4. We had written this reaction, isn't it? This reaction, 2 KMnO4 plus 3H2SO4 giving K2SO4 plus 2MnSO4 plus 3H2O plus 5 nascent oxygen. Okay, so this is the reaction of KMnO4 in acidic medium. That we already discussed this particular reaction. Then in alkaline medium, the second one, in alkaline medium or in neutral medium. In alkaline or neutral medium, 2 KMnO4 plus H2O. That means we are writing the reaction in a neutral medium. The product will be potassium hydroxide, manganese dioxide plus 3 molecules of nascent oxygen atom. Okay, 2 KOH. Here it will be having 2 MnO2, isn't it? So in alkaline medium or a neutral medium, here we are writing in the case of a neutral medium. That means in water it will be we will be obtaining potassium hydroxide, manganese dioxide and nascent oxygen. Then the next one, some of the reactions of permanganate, that is the oxidation reactions of permanganate in acidic medium. Okay, so for acidic medium, this is the base reaction in acidic medium. So next is the some of the conversions happening in acidic medium. Some of the conversions or reactions going on in acidic medium. First one, ferrous ions are converted to ferric ions, that is Fe2 plus, it is oxidized to Fe3 plus in the presence of KMnO4. That is the first reaction. So you have to study the overall reaction. So the reaction will be MnO4 minus. MnO4 minus means it is KMnO4, isn't it? So KMnO4 plus 5Fe2 plus, that is ferrous sulfate. It can be ferrous sulfate plus 8H plus giving Mn2 plus plus Fe3 plus plus 4H2O. Okay, so here in this reaction, see, Fe2 plus, it is oxidized to Fe3 plus, isn't it? Here oxidation takes place. Here oxidation takes place. Fe2 plus is oxidized to Fe3 plus, while manganese here it is reduced to Mn2 plus, isn't it? So this is the first reaction, conversion of ferrous to ferric or oxidation of ferrous to ferric reaction. Then the next one, oxidation of oxalates or oxalic acid to carbon dioxide. Second one, oxidation of oxalates or oxalic acid to carbon dioxide. So that is the second reaction. So this reaction 2MnO4 minus plus oxalic acid. Oxalic acid, the formula is H2C2O4, isn't it? So while writing it as in the ionic form, we can write it as C2O4 2 minus, isn't it? That means 2H plus will be going instead. Here it will be having C2O4 2 minus. So we can write it as 5C2O4 2 minus plus 16H plus, giving 2Mn2 plus 10 CO2 carbon dioxide plus 8 H2O. So this is the conversion of oxalates to carbon dioxide. This oxalates, it is oxidized to CO2 gas. That is the next reaction. Then again the another reaction, oxidation of iodides to iodine. Oxidation of iodides to iodine. Here in this oxidation, C2MnO4 minus plus 10I minus, that means it can be potassium iodide Ki, plus 16H plus. Here H plus means sulfuric acid, giving 2Mn2 plus 5I2 plus 8H2O. Here also see this iodide ion, it is oxidized to iodine. I minus is oxidized to iodine. So here also KMnO4 helps in the oxidation process. Then the next reaction, the fourth reaction, sulfides to sulfates, that is ITE to ATE. Sulfides to sulfates, ITE to ATE, ITE, ATE. Here this sulfides, that is SO3 2 minus plus 2MnO4 minus plus 6H plus. This is sulfite ion, Na2SO3, that is sulfite, Na2SO3. So here it becomes, in the ionic form, it becomes SO3 2 minus, giving 2Mn2 plus 5SO4 2 minus plus 3H2O. Okay, this is the reaction. SO3 2 minus, that is sulfite ion, it is oxidized to sulfate ion, SO4 2 minus. Then the next reaction, the fifth reaction, sulfur dioxide is oxidized to sulfuric acid. Oxidation of sulfur dioxide to sulfuric acid. See here again 2MnO4 minus plus 5SO2 plus 2H2O. The product will be 2Mn2 plus 5SO4 2 minus plus 4H plus. See here this sulfur dioxide SO2 gas, it is oxidized to sulfuric acid. SO4 2 minus means H2SO4, isn't it? So this oxidation takes place in the presence of KMnO4. Then the next reaction, halogen hydracids. Halogen hydracids are oxidized to halogens. Halogen hydracids are oxidized to halogens. See here, you have to write down the equation, 2MnO4 minus plus 16H plus. Halogen hydracids means it can be HCl, isn't it? Plus 10X minus 10HX, okay, giving 2Mn2 plus 8H2O plus 5X2. See here, this is the halogen hydracids and this is sulfuric acid. This is the part of sulfuric acid and this is halogen hydracids, that means HX, okay, 10X minus. So here this halogen hydracid, that means this HX, it is oxidized to halogens, X2. Here if it is HCl, then here we will be having Cl2. If here it is HF, then here we will be obtaining F2. Okay. Then the next reaction, the seventh reaction, nitrites to nitrates. Nitrites to nitrates. Nitrites to nitrates. That means nitrites, the formula is HNO2, isn't it? So we can write it as NO2 minus plus 2MnO4 minus plus 6H plus giving 2Mn2 plus 2Mn2 plus 5NO3 minus, that is nitrate ion, plus 3H2O. Okay, so this is the reaction, that is nitrites, that is HNO2 or NO2 minus, it is oxidized to NO3 minus or HNO3. Okay, here also oxidation takes place in the presence of KMnO4. So these are some of the reactions in acid media. Okay, so these are some of the reactions. I think there is no need for telling you it once more, otherwise you can go through the video once more. If any doubts, you can call me. Then the next one, oxidation of KMnO4 in alkaline medium. So till now we are seeing this oxidation reaction in acidic medium. So then the next one, that is in alkaline medium. So first reaction, oxidation of iodides to iodate. Iodides to iodate. That is IDE to ATE. Okay. So here the equation, it will be like this: 2MnO4 minus plus H2O plus I minus giving 2MnO2 plus 2OH minus plus IO3 minus. See here, this iodide ion, iodide means HI or Ki. So here this is the iodide ion, it is oxidized to iodate. Iodate, the formula is IO3 minus or HiO3, like that. Okay, so this is the oxidation reaction in alkaline medium. Then the next one, ethylene to glycol. Ethylene to glycol. Ethylene to glycol, that is ethylene, the formula is CH2 double bond CH2, isn't it? That means we can write it as C2H4. The molecular formula is C2H4 in presence of water plus oxygen. On oxidation, this ethylene, it will be converted to glycol. Glycol or ethylene glycol, that is CH2 single bond CH2 OH OH. So this is ethylene glycol, or simply we can say it as glycol. Ethylene glycol or glycol. Okay. So then the next reaction, toluene to benzoic acid. Toluene to benzoic acid. See here, toluene. What is the formula for toluene? C6H5CH3 plus oxygen, nascent oxygen in the presence of KMnO4. So this, see, in any benzene ring or aromatic ring compounds with a side chain, the side chain, it will be oxidized. That means CH3 group, it will be oxidized to COOH. Irrespective of any number of carbon atoms present in the side chain, the product will be benzoic acid. Okay, so this is COOH, benzoic acid plus water. Then the next is in neutral solution. So we have seen so far in acidic medium as well as in alkaline medium. Then the next one is in neutral medium. So the first reaction in neutral medium, hydrogen sulfide, it is converted to sulfur, or hydrogen sulfide is oxidized to sulfur. So the reaction will be 2MnO4 minus plus 3H2S hydrogen sulfide. Then the products will be MnO2 manganese dioxide plus 3 sulfur plus 2H2O plus 2OH minus. Okay, that is the first reaction. Then the second reaction, sodium thiosulfate, that is Na2S2O3. Sodium thiosulfate, it is oxidized to sodium sulfate and sulfur. Sodium thiosulfate is oxidized to sodium sulfate and sulfur. So write down the equation, 2MnO4 minus plus sodium thiosulfate, the formula is Na2S2O3, that is we can write it as S2O3 2 minus. Okay, S2O3 2 minus 3 molecules plus H2O giving 2MnO2 plus 3SO4 2 minus plus 3S plus 2OH minus. Okay. So this is the conversion of sodium thiosulfate. Here it is oxidized to sulfur. And then the third reaction in neutral medium, that is conversion of NO2 nitrogen dioxide to nitric acid HNO3, oxidation of NO2 to HNO3. Again MnO4 minus plus H2O plus NO2, 3 molecules of NO2 giving 3 NO3 minus nitrate ion plus MnO2 manganese dioxide plus 2H plus. Okay. So here also MnO4 minus it is reduced to MnO2. At the same time NO2 is oxidized to NO3 minus. Here it is the oxidation process and here it is the reduction process. Okay. So next is some of the uses we can go through, your uses of KMnO4. Okay. So this much you have to go through all the reactions in acidic medium, in alkaline medium as well as in neutral medium. Then the next is the uses of potassium permanganate. So the first use, it is used as an oxidizing agent. Used as an oxidizing agent in usually in lab we are using, as well as in industry also. This potassium permanganate, it is used as an oxidizing agent. Then the second one, it is used in the manufacture of saccharin. Manufacture of saccharin. Saccharin, it is a sweetening agent, isn't it? Saccharin, acetaldehyde, manufacture of saccharin, acetaldehyde, then benzoic acid. Then the third one, normally you have seen sometimes in our wells, etc., we are using KMnO4, potassium permanganate is added. That is, it acts as a disinfectant. Okay. Potassium permanganate acts as a disinfectant for water. Usually for in our wells, etc., we are using this potassium permanganate. Okay. Then the fourth reaction, for volumetric estimation we are using permanganate. That is, this potassium permanganate estimation, it is called as permanganometry, isn't it? Permanganometry, potassium permanganate estimation using potassium permanganate, it is called as permanganometry. And also in this permanganometry we are estimating this ferrous salt, then oxalates, oxalic acid, etc. Then nitrous acids are there, that is nitrous acids, HNO2, then nitrites, etc. We are estimating by using this potassium permanganate. That is the next use. And also usually in this while using KMnO4 we are adding sulfuric acid along with it. Don't forget about the addition of sulfuric acid. That is, normally we are using in an acid medium. See, in acid medium means we have got a chance for adding HCl. What is the purpose of adding H2SO4 itself? In all these reactions we had seen the addition of sulfuric acid alone. The three acids are there, isn't it? Strong acids, that is HCl is there, H2SO4 is there, HNO3 is there. But see, in permanganometric estimations we are using only sulfuric acid. The other two we won't use. See here, if HCl is used, what happens is that HCl will be oxidized to chlorine gas, and hence the estimation will go wrong. And also if we are using nitric acid, see, nitric acid itself, it acts as an oxidizing agent, therefore it will be affecting the reaction. Okay, nitric acid itself is an oxidizing agent, so therefore oxidation process will this reaction cannot be carried out in the presence of nitric acid. So that is why we are using sulfuric acid. Okay, so this is in your lab exams, usually this question will be asked in your viva part. Okay, why sulfuric acid is used for permanganometric estimations, not HCl or nitric acid. Okay, so this also you have to read that point also. So these are some of the uses of potassium permanganate. So in our next session we can go through the inner transition elements, that means lanthanides as well as actinides. Okay, thank you.